Okay, this is probably my sixth take, but I'm gonna start right ahead. This video is about determining the density of pennies, lab number 5. Okay, so what we're gonna be doing is you wanna grab 5 pennies that are between 1962 and 1981, preferably pennies that are not rusted or are not misshapen, because if they're misshapen, it would be hard for you to get a very good column. You have a lot of extra space between your pennies, and that will overinflate your height. The second set of 5 pennies should be between 1982 and present. So you can find any penny that's minted after 1982. You want to weigh your 5 pennies. So I'm just going to go straight to it. Let's say you weighed your 5 pennies and your pennies came out to around 10 grams. So this is the weight of your 5 pennies. Remember, weight is going to be listed in grams. And by the way, when you download the help folder or the help sheet, I do have some notes here for you, but I'm just going to keep going straight. Okay, for the height of the column of the pennies, the 5 pennies, you want to stack them, and you can use a wrench. The direction says use a wrench if you have a crested wrench to hold these pennies tight as you measure the height of the pennies. If you don't have a wrench, don't worry about it. You don't have to go to the store and get the wrench. You can be creative and just measure the thickness of 1 penny. So for the sake of the lab, let's pretend the thickness of 1 penny is about 0.5 centimeters. I'm making up numbers so I can actually walk you through the math. But then since we have 5 pennies, the 5 pennies will total, so this is going to be times 5, should be 2.5 centimeters, right? Because we have 5 pennies total to make that column. For the radius, you want to take your penny and then look at it from the top. You want to measure the thickest part of your penny from one end to another. Let's pretend that was the thickest part, and I'm going, I'm drawing a line that bisects the penny. That will be your diameter. So your diameter, for the sake of our math, let's say our diameter is 1 centimeter. But what we want is the radius, not the diameter. The radius is the diameter divided by 2. So that will be 0.5 centimeters. Somebody really likes 0.5. That person will be me. 0.5 centimeters. Okay. Let me make sure I am sharing and I'm recording, because, wait, am I sharing? I think I am sharing. Am I recording? Yes, I'm recording. Okay, y'all, I recorded almost all the way through and then realized I wasn't sharing my screen. You know how annoying that is? Since I'm doing this by myself, there's nobody on the other end. They can't tell me, hey, professor, you're not sharing your screen. I miss those days. Anyways, focus back here. Since we have this right now in direction number, I think, in direction number, hold on a second, give me just a moment. Direction number 11. It does give you the formula of figuring out the volume. The volume is equal to pi r squared times height. Okay. So I want to bring this in, but I'm afraid that this is what's messed up the video, because at some point I couldn't write on here. So I'm just going to write my actual numbers. You're going to put in pi in your calculator. Our radius here, for the sake of conversation, is 0.5. We're going to square that. And then our height is 2.5. So when you work all this out, remember this is 2.5. I ended up with, let's see, a volume of 1.963 centimeters cubed, okay? And that's our volume because the volume is recorded in centimeters. Then to get our density, they say to take the gram number, that will be the mass right here, divided it by centimeter cubed, the volume. So your density is mass divided by volume. And when you work it out, you end up with 5.093 gram per centimeter cube. So you write the number here, and this number is essentially dP1, also known as the density of penny 1. So let me go ahead and erase all these numbers. I'm trying to stick with doing all my math right here so that I am not all over the place, right? I'm trying to navigate less because I have recorded this video so many times. This is like the 6th take. So I don't want to have to do it again. So let's say that density of copper, these once again are not true numbers. They're not the actual numbers. So let's say we found the density of copper to be 6.00. If you don't have the value in your book, you can find it in a reliable source. You can find it from a reliable source online. Then the other made up density of zinc is 4.50. I'm just making these numbers out to show you how they should work out. So we're asked here, after we have done all this gathering of values, to go ahead and fill this part here. So we have 2 samples to pick from. I'm going to be working on the first one, so 1962 to 1981. That's my first sample's ID. And we want to know what the percent of copper is and the percent of zinc. Okay. So percent of copper will be symbolized by A1, percent of zinc will be symbolized by B1. So for that, what I'm going to do here, it tells me to get A1. So I'll just write it here. Let me go back, click on that. To get A sub 1, you're going to divide dP1. That's this number right here, density of penny 1. So that should be 5.093. I'm not going to use units because it takes up too much space. Minus density of zinc. Density of zinc is DZN. This is right here. This is essentially DZN. This is DCU. So DZN, sorry, that's 4.50. So that will be our numerator, right? Subtract that and then divide it by DCU. DCU is density of copper. That will be 6. Oh, no. What am I writing the symbol for? Come on. I become, yeah. So 6 points. I'm saying 6 and I'm writing DCU. Okay, 6.00. Excuse my horrible handwriting. I'm writing with a mouse. And then let's see, minus DZN. DZN is 4.50. So we have a numerator, we have a denominator. You want to work on that, and then that will give you your answer. So let me set this up here. 5.093 minus 4.5. For the top number, I do get, it's what happened here? For my top number, I get 0.593 divided by my bottom number should be 6 minus 4.5 should be 1.5. So 5 by point. Divide this number. And I get 0.395. So this is my A1, right? Now, since it says percent, you can multiply by 100 to get percent. So I'm going to multiply by 100, and I get 39.5. Please don't use these numbers. I will know. Okay. You can't use my made up numbers. These are not real. These are just made up. But that will be my first calculation right here. Then for A2, sorry, that's not how it works. Then for B, let me just erase this. I'm unintentionally being lazy. Then for B1 is what I'm solving for next. For B1, I take DCU, so density of copper, 6.00 will be my numerator, minus DP1, minus density of penny, 5.093 divided by, the denominator is the same as what we had before. So it'd be 6 minus 4.5. So close parentheses, close parentheses. I know my denominator is still 1.5. It's the same as what I had up here because the denominator part is the same. You see that for B1, the same as for A1. The top part is the part that's different. So I'll put here 6 minus 5.093. I'm getting 0.907 divided by 1.5. Okay, so I'm getting B1 as equal to 0.605%. Oh, so sorry, it's not percent. I actually need to get B1. So to get a percent, I multiply by 100 and I'm getting 60.5. So here I'm getting 60.5. Based on my made up numbers, these are my percentages. So according to my experiment with my made up numbers, I am saying that the pennies between the years 1962 and 1981 had more zinc than copper. The zinc percent was 60.5%, and then the copper was 39.5%. Remember, these percentages have to add up to 100. And then the percent can't be less than 0, and the percent can't be more than 100. Okay, the percent can't be negative either. It has to be a positive value, bigger than 0. Sorry, less than 100. So I have done the first part with fake numbers. The second part for A2, B2, of course, this time I'm using density of penny 2. The bottom part is going to be same as up here, right? Density of copper minus density of zinc. That bottom part is the same thing as what we had up here, only you're using different symbols at different points. This part here, we are ignoring. I ignored that part and I ignore this part here. That's just a means to an end. This is a calculation that led to finding A1 and B1, and then A2 and B2. So that's it. Hopefully this makes sense. Let me stop sharing.